further. Okay. So what I mean by that statement, why I'm saying, okay, when the denominator is 0, and that's probably where I would stop in pre-calculus, and the discontinuity is non-removable, is because it is possible to have something, and I showed you something like this the other day. Okay. And so, if I said to you, where are the vertical asymptotes, what should we do to kind of investigate that further? What does the bottom factor into?
X plus 5, x minus 3.
Okay. So then if I was going real quickly, I'd say, okay, this has asymptotes at -5 and 3, because those are the zeros of the denominator. But, now, here's the deal. The function is definitely not defined at -5. Okay, and even though this is going to be a discontinuity, because at any point where the denominator is 0, it's not continuous. But does it look like an asymptote? It doesn't. It actually looks like a hole when it's removable. Remember that from the other day? So it is not continuous at -5 and 3, but the only one that shows up as a vertical asymptote is going to be x equals 3. And let's look. Okay, so there it is at x equals 3. We obviously don't see. If you would hit trace, it would just be a little hole in the graph there. Okay? Okay. So what does it mean to be a vertical asymptote? What that means is that the function value, the y value, is either approaching positive infinity or negative infinity as x approaches some number. Okay. So we can then evaluate limits around asymptotes. Let's take a look at this. Let's describe the function around the asymptote using a limit. So let's do from the right first. What's the limit as x approaches 3 from the right? We would write with a plus sign of f of x. Technically, by the definition of the word limit, it's not a number, so we would say doesn't exist, but it goes towards or approaches. What's it doing? Approaching infinity. But you can just write infinity. You would never get, in this class, deducted for writing that. I might say on a test, if the limit approaches, if it doesn't exist but approaches infinity or negative infinity, state that. All right, how about the limit as x goes to 3 from the left then?
Approaches negative infinity.
Approaches negative infinity. And so I could write that like that. Okay, now let's flip over and do some limits. Absolutely, we should use graphs, but if you don't have a graph, you can just use some common sense about what kinds of numbers. If we know it's going to be around an asymptote, and we know that it's going to either be positive infinity or negative infinity, and we don't have access to a graph, what do? So over here, 1 makes the bottom 0, correct? And it's non-removable. So we would know it's an asymptote. So if you want to know if it's going to be positive infinity or negative infinity, put something to the right of 1 in and see if it's a positive or negative number. Pick something. 2. 2 plus 2 is positive. 1 minus 2 is positive over negative. What do you think this is going to be?
Negative.
Negative infinity. Let's check it out and see. Were we right? This was from the right. Yep. Okay. All right. Let's factor this. Uh-oh. Does that work?
Yep.
I'm not sure if the top's factorable or not. The only reason that I'm asking this is because if it's, I'm trying to do it without graph. I might have to, if it's removable, then it wouldn't be an infinity, negative infinity thing. Okay. 2 and 3. Crap, I can't do this with a pen.
3x minus 1, 2x minus 1.
Sure. Minus 2x. Yep. Good job, Aiden. Okay, so in this case, what do we do now, because this is not an asymptote, right? Yep. So these are removable. So what we can do around, because it's a negative 1/2, is we can put in something close, but just put it in up here, okay, to kind of see if we can figure out what it approaches. So what's close to negative 1/2? But like it's coming from the right. Do you want to try 0? Okay. So my guess then would be that it would approach looks like 1/3 ish. Oh no, we can actually put 1/2 in now. Silly me, right? Can't we put 1/2 in? Because we removed it. Dum. All right. What's 3 times negative 1/2? Do you see why I'm covering that up? Because I'm trying to ignore it. All right. So 3 times negative 1/2 is negative 1.5. Minus 1 would be negative, no, the top. Oh, on the bottom you mean. Yes, it is. Thanks, Jim. All right, so now 2 times negative 1/2 is negative 1. Negative 1 minus 3 is? Negative 4. Okay. So what's negative 2.5 divided by negative 4?
2.5
Well, we could do this.
Oh, I could do that. That's 5 over 8, 5/8.
Sure. So I just rewrote 2.5 as 5/2 divided by 4, which is 5/2 times 1/4, which is 5/8. Okay, so asymptote, plug in a value close to get the behavior positive or negative infinity. Removable, remove it, plug the value in. How about this one? Can I remove this? No. So this is definitely going to be an asymptote, right? So what do you want to try to do? Let's pick in something to the left of 0 just to decide if this is going to be an infinity or negative infinity situation. So negative 1?
Yeah.
Okay. If I picked negative 1, something to the left of 0, that would be negative 1 squared minus 1 over negative 1, which is 1 plus 1, isn't it? Are you following that with all those negatives? Which is to a positive number, I'm thinking that that's going to approach positive infinity. Let's look. It's a little hard to see, but do you see how that curves and is coming up? So it is approaching positive. Okay, so then let's do a trig one. By the way, this is the same as the function negative 2 secant of x. So if you see secant, sorry, you need me to move it down. If you see secant or cosecant today, you can rewrite them in this way. I do like it like this. Okay. So this is where it's helpful to have our information of the unit circle. So on the unit circle, here's pi halves, and this is the ordered pair 0, 1, which means the cosine at pi halves is what? 0. Okay. So obviously this is undefined, non-removable. Let's plug a value in that's to the right, and all we need to know, we don't need to know what it is exactly, we just need to know its sign, because if it's undefined and non-removable, there's going to be an asymptote. Let's say I picked any of these, pi fourths, pi thirds, pi sixths, pi fourths, pi thirds. The cosine is going to be what kind of number? Positive. So what I have then, if I pick something to the right, is a negative divided by a positive. What's the result going to be? Negative. So this is going to go towards negative infinity. And you can just watch me. I'll put this in. Oops. Here's this. I'm going to just go only to pi. Let's put a tick mark at the pi half so we can see it. So this tick mark right here is positive pi halves. I'm coming from the, oh wait. Well, oh, for Pete's sake. This is just, this, I can tell you, has been a day already. I woke up in the 7s this morning. What would happen if you woke up in the 7s? I was frantic. Yes.
Oh.
Yeah, think about that. School starts at 7:40 and I woke up in the 7s, so I've been scrambling ever since. What did I do incorrectly?
Wow.
Can you guys tell me what did I, because this clearly shows this is positive infinity. When I plugged in these values, I was thinking, because I was on the right on the graph, but really on a number line, these are from the last. These numbers are less than pi halves. This is 90 degrees. Isn't 30 degrees less than 90 degrees? I was plugging in a value from the left, and I should have put something in from the right. All right, let's recalculating. All right, over here, I'll do this. Cosine of 3 pi fourths. So we are. This is 3 pi fourths is to the right of pi halves, correct? Think numerically. Okay. Is the cosine of 3 pi fourths a positive or negative number? Negative. So this should be a negative. So a negative divided by a negative is a positive. This should approach positive infinity. Wow, wow, wow. Okay.